Bismillahirrahmanirrahim. Assalamu alaikum. My dear students, I hope you all are doing well. Today we will start the second lecture on units of concentration, and it will be very much helpful for the senior students, especially for A levels and HSC, and also for SSC and O level. But we can start the next topics which were not given in the first lecture of units of concentration. So, dear students, we will start inshallah. Okay, this is the second lecture topic, units of concentration, lecture number 2. In the last class, we have discussed about percentage concentration and molarity. Now, we will do conversion of percentage concentration into molarity or molar concentration, my dear students. So, this is the topic, first topic. One question: what is the molarity of 5% W by V sodium carbonate solution? Okay, a very simple question. Just we will convert this percentage. Look at here, my dear students. Percentage concentration will be converted into molarity. Your total solution volume may be 1 liter, 2 liter, 3000 liter, whatever, but we will just convert this percentage concentration. Okay. Now, here 5% means 5% W by V sodium carbonate means 5 gram Na2CO3 is dissolved in every 100 ml solution. So, look at here, my dear student. This 5% meaning is this, that 5 gram sodium carbonate is dissolved in every 100 ml solution. I repeat, your total container volume, total solution volume may be 30 liter, 20 liter, whatever, but if in this container it is written 5% W by V sodium carbonate. So, now what is the meaning of this? The meaning of this 5% sodium carbonate is 5 gram sodium carbonate is dissolved in every 100 ml of solution. Okay. It doesn't mean that total volume is 100, but it means that every 100 it contains 5 gram. Okay. Now, we know that molarity formula is S equal to 1000 W by mV. So, here W is what? 5 gram. Molecular mass of your sodium carbonate, molecular weight of your sodium carbonate, you know that it is 106 gram per mole. So, we can put here 106 and here volume is 100. Why 100? Because in every 100. Okay, now do the calculation. Okay. So, if we do the calculation here, 106 into 100. So, what will be the result? 0.47. Okay. Now, the final is 0.47 molar. Okay. So, the meaning of this 5% sodium carbonate and this 0.47 molar the amount or concentration amount is same, but they are expressed in different units. One is percentage unit and another is what? Molarity unit. I repeat, here it is percentage unit or percentage concentration unit, or here in the molarity unit. Okay. So we can convert the percentage concentration into molarity in this way easily. Okay. Now we can do the reverse again, molarity to percentage. I repeat, molarity to percentage. Okay. Now do it reverse. Do it reverse. Now conversion of molarity into percentage concentration. Percentage concentration. Look at here. Now another question. What will be the percentage concentration for 0.5 molar sulfuric acid? Now what is the formula for that? X equal to Sm by 10%. Look at here, my dear student. So by this formula we can easily convert the molarity into percentage. Here S is molarity and M is molecular mass and X is percentage concentration. So now put the values here. S is here 0.5 and molecular mass of 98 for sulfuric acid, and here it is 10. So if we do it, then what will be the result? Our 0.5 multiplied by 98 equal to this, divide 10, so it will be 4.9. okay. So it is what? 4.9. So it is of 4.9%. So this is 4.9%. okay. So 0.5 molar sulfuric acid and 4.9% sulfuric acid, the same thing, same concentration, but expressed in different units. okay. So this is another conversion, molarity to percentage concentration. I think it will be clear for you. Now the next topic. Now my dear student, we will do the another topic, that is molality. Molality. The number of mole of a substance dissolved in 1000 gram or 1 kg solvent. I repeat, here we have to use solvent. Molality is counted considering solvent, not solution. So dissolve in 1000 gram, dissolve in every 1000 gram or 1 kg solvent, then it is called molality or molal concentration. So how can we do an example with formula derivation? okay. So this is the just we have write down the definition. Now go to the formula derivation through an example. okay. Now my dear student, look at here. One question will make you clear about the formula of molality. For example, what is the molality? What is the molality? Molality of 2% W by W HCl or sodium hydroxide. Just one thing, sodium hydroxide. Okay. Now, my dear student, look at here. We will find out the molality or molal concentration of 2% W by W sodium hydroxide. Okay. Now, look at here. Answer or solution: 2% W by W NaOH means so dear student, here 2% W by W sodium hydroxide means 2 gram sodium hydroxide is dissolved in 100 gram of solution. Now, so 2 gram solute is dissolved in every 100 gram of solution. That means here solute is 2 gram and rest of the part for solvent mass for every 100 gram of the solution. Okay. So, mass of the solvent equal to what? 100 minus 2 gram. It means that is 98 gram. This is solvent. Now, using this 98 gram solvent, we have to find out molality or molal concentration. Now, look at here. How will we solve this? My dear student, look at here. 98 gram solvent contains what? Contain 2 gram sodium hydroxide. But we will do the molality concept. So, this gram must be converted into mole. How? We know that mole number can be easily find out given mass by molecular mass. So, in mass this is 2 gram is true, but in mole number this gram is, if divided by the molecular mass of sodium hydroxide, that is 40, then it will be mole. I repeat, 98 gram solvent contains in gram, that is 2 gram sodium hydroxide. I repeat, 98 gram solvent contains 2 gram sodium hydroxide. This is correct. But if we consider in the mole for sodium hydroxide, so that 2 gram divided by molecular weight 40, then it will be mole. Okay. Now, same amount is present, but it is expressed in the mole, and that was gram. Okay. So, 1 gram solvent contains 2 by 40 into 98. Now, for 1000 gram or 1 kg solvent, it will be 2 into 1000 divided by 40 into 98. Now, we have to do the calculation. Okay. Look at here. We have to do the calculation. 2000 divided 40 multiplied by 98. So, it will be what? 0.5. 0.5. Okay. So, it is 0.5. So, 0.5 molal, small m, not capital M, small m. So, from this calculation you can easily find out the formula of molality. My dear student, this is very, very important for you. Look at here, everyone. Molality equal to this 1000 grams for the formula, there is 1000 gram consideration. So, this is 1000 and here 2 is the given mass. So, that is W. Now, 40 was what? Molecular weight of sodium hydroxide. So, it is molecular weight, and the 98 is what? Mass of the solvent. Mass of the what? Solvent. You can symbolize mass of the solvent by the another symbol V or XYZ, whatever, mass of the solvent. It's up to you. Just I am making here the formula of molality. So 1000 W divided by capital M, that is mass of the solvent, and capital M is molecular mass and mass of the solvent. Okay. Now this is the percentage to molality. Okay, we have done molality definition and an example. Okay, now ppm concentration. ppm means parts per million, parts per million, parts per million, and you know that multiplying factor for million is 10 to the power 6. So what should be the definition? The amount of solute, that is gram or ml dissolved in every 10 to the power 6 parts gram or ml parts of the solution is called what? ppm concentration. Now my dear student, look at here, same types of definition we have given in the percentage concentration in my lecture 1, but the thing is that here amount of parts is 10 to the power 6, but in percentage concentration it was 100 or 10 to the power 2. So when amount of solute dissolved in 100 parts, that is percentage concentration. When it is dissolved in 10 to the power 6 parts or per million parts of the solution, then it is called what? ppm concentration. So basic difference is here multiplier factor is 10 to the power 6 for ppm, percentage for what? 100. Now just make a difference between this percentage concentration through a simple formula expression. You know that for percentage concentration W by V, it was what? Mass of the solute. Here W means mass or weight, here V is what? Volume. So mass of the solute in gram divided by volume of the solution in ml multiplied by 100 or 10 square. 10 square and 100 is same. So it is 10 square for what? Percentage concentration. But it will be more same, it will be just same, this part just only different here 10 to the power 6 when it is what? ppm. So if it is ppm concentration W by V, ppm concentration, then what will be the expression? Similar, mass of the solute in gram divided by volume of the solution in ml by 10 to the power 6 multiplied by 10 to the power 6. Just look at here, my dear student, that I am trying to make you understand that the difference here only multiplier factor is 100 and here 10 to the power 6, and nothing is different between these two types of concentration. So don't be worried about that. So when it is ppm concentration, then just multiplier factor what? 10 to the power 6. Okay. Now another thing is molarity to ppm. Molarity to ppm, and ppm to molarity. This is very necessary conversion for you. For example, question is what? 0.5 molar H2SO4 will convert into what? ppm. Another information for you that 1 ppm equal to 1 milligram per liter. This is very important information is that ppm and milligram per liter is same thing. ppm concentration and milligram per liter is same thing. Okay. Now, how can we convert S equal to 0.5 molar H2SO4? So, here 0.5 molar means 0.5 mole per liter. Okay. You know that sulfuric acid molecular mass is 98. So, molecular weight is here 98, and you know that 98 gram sulfuric acid means what? 1 mole. So, if we want to convert this mole into gram, we have to multiply by the molecular mass, because we know that mole number equal to given mass by molecular mass. So, if we convert into weight, then multiplied by the mole number by molecular weight. Okay. So, 0.5 into 98 mole becomes what? Gram per liter. Now, this is gram per liter. Now, we have to convert this gram into milligram. Okay. Now, 0.5 into 98 into what? Milligram is 1000. So, gram becomes what? Milligram per liter, and you know that milligram per liter is ppm. So, you can write this milligram per liter as ppm or directly ppm, both are correct. Okay. Now, if we do the calculation, then what will be the result? Four five triple zero. Okay, 45000 ppm. Okay. Now, we can do it this ppm into molarity again to the 0.5. How? Question is what? 49000 ppm to molarity. Molarity. Look at here. So, what is the concentration here? 49000 ppm. You know that ppm means what? Milligram per liter. So, milligram to gram, how can we do it? Milligram to gram divided by 1000. Okay. So, 49000 divided by what? 1000. So, it will be what? Gram per liter. So, here 000 49. So, gram per liter. Now, we have to divide this gram by their molecular weight. So, it will be mole, because we know that the formula of mole is given mass by molecular weight. So, if we want to convert the given mass into mole number, then we have to divide by the molecular weight. So, 49 divided by 98 molecular weight, then it will be gram into now mole. Now, gram is converted into what? Mole, and per liter as it is, then we will get 0.5 mole per liter, or you can write 0.5 mole. So, very simple, we have converted this 0.5 molar H2SO4 to ppm, and here 49000 ppm to molarity. So, it is very important interconversion of your maths. Okay. Now, the next. Dear students, now we can start another topic, that is what? Normality. Okay. So, what is normality? At particular temperature, the number of gram equivalent weight of a substance of a substance dissolved in every 1000 ml or 1 liter solution is called normality of that solution. Okay. So, here temperature is counted because here volume is related. Okay. In molality, temperature is not required to mention in the definition because that is not related to the volume. You know that temperature is related to the volume and vice versa, but not mass. So, when your molality is counted, temperature is not mentioned because mass is not changed with temperature, but volume is changed. That is why in normality definition and molarity definition, where volume is counted, then temperature counted in ml or like these types of unit, ml, liter, whatever, then it must be mentioned the temperature. But when molality, only molality, then that is counted in the mass unit for the solvent. That is why temperature is not required there. So, very simple, molality is not dependent on temperature, not dependent on temperature. I repeat, molality is not dependent on temperature, not dependent molality, okay. But normality, molarity both dependent on temperature. I repeat, molarity and normality both depends on temperature, okay. So, both depends on temperature, but molality does not, okay. Now, we will find out the formula of normality. Okay, here one thing is new, that is number of gram equivalent weight. So, what is gram equivalent weight? Gram equivalent weight equal to molecular mass divided by equivalent number. Okay. So, for example, sodium carbonate, molecular weight is 106 gram and equivalent number is 2. Equivalent number is what? Equivalent number is 2. How? In case of sodium carbonate acid base, we can easily do that like this way. Here number of positive charge is 2, number of negative charge is 2. In case of, for example, sodium hydroxide, here plus and here minus 1. In case of sulfuric acid, H2SO4, number of positive is 2, number of negative is 2. So, here we will count the number of positive or negative charge total in these molecules, number of positive and negative charge in these molecules, just value or magnitude, not the sign negative, okay. Now, equivalent number of sodium carbonate is 2, sodium hydroxide is 1 and sodium carbonate is 2, sulfuric acid is 2, okay. So, if we use this formula, then what will be the gram equivalent weight for sodium carbonate? So, 106 gram, equivalent number is 2, that is what, 53 gram. So, very simple, gram equivalent weight of sodium carbonate is 53. So, in case of sulfuric acid, if we do it, gram equivalent weight of sulfuric acid, so what will be the value? It is 98. So, 98 gram divided by what? 2, that is 49 gram, okay. So, in case of sodium hydroxide, what will be? Gram equivalent weight of what? Sodium hydroxide, it will be 40 divided by 1, that is 40 gram, okay. Now, so if we divide the molecular weight by their equivalent number, and we can easily find out your equivalent number by this way. Another way is also present in electron donation, receiving, whatever. Just we are trying to find out the equivalent number of these molecules easily and find out the equivalent weight of each substance. Okay. Now, sulfuric acid is 49, it is what 53, it is what 40 gram. Now, what was our definition? This is the very simple your equivalent weight calculation. Okay. Now, let do here another question. How many number of equivalent weight is present in 98 gram H2SO4? How many number of equivalent weight is present in 98 gram H2SO4? So, very simple, you know that H2SO4 molecular weight is what 98 gram, and you know that the equivalent weight is here 2, so it is 2. So, equivalent weight of H2SO4 equal to 98 by 2, that is 49 gram, you know that. So, 49 gram H2SO4, okay. Look at here, 49 gram H2SO4 equal to 1 equivalent weight of key H2SO4. It's very simple. So, 1 gram equal to what? 1 by 49. Now, 98 gram equal to what? 98 by what? 49, that is 2. So, number of equivalent weight, I repeat, number of equivalent weight is present in 98 gram H2SO4 is what? 2. If 49 gram H2SO4 is 1 equivalent weight of H2SO4, then 98 gram is what? 2 number of equivalent weight. Now, here is the very important information is hidden to you, that is 98 by 49. So, what is this? Now, look at here, number of equivalent weight equal to given mass. 98 is what? Given mass divided by equivalent weight. If we do it, then we will get number of equivalent weight. Similarly, we have designed another formula, number of moles. It's very simple, number of mole, you know that N equal to given mass by molecular weight. That means, when we want to convert a given mass into their molecular weight, then, so dear student, look at here, number of mole can be calculated given mass by molecular weight. Similarly, number of equivalent weight can be calculated in this way, given mass by what? Equivalent weight. Okay. So, just I am comparing these two formula to easily remember by yourself. So, look at write down this. Now, for example, now let a VML solution of any substance, VML solution contains W by equivalent weight, that means given mass by equivalent weight, number of equivalent weight of a substance, okay, of a substance, okay. Again, VML solution contains this number of what? Equivalent weight of a substance. Now, 1 ml solution contains W by equivalent weight into V. Now, for 1000 ml, 1000 W divided by equivalent weight into V. Now, this is the formula derivation. S equal to normality equal to 1000 W divided by equivalent weight into V. So, this is the another formula for your normality calculation. Okay. So, now finally, we will just make a relationship between normality and molarity, then we will end this lecture. Then the lecture 3 we will do more maths mentioning the all formula. Okay. Now, the last formula for you is very easy. You know that relationship between molarity and normality. Okay. You know that S equal to 1000 W by what? M into V, and normality you have already find out 1000 W equal to equivalent weight into V. Equivalent weight into what? V. V into equivalent weight. Okay. Now, 1, this is 2. So, divide this, 1 divided by 2. So, S by N, 1000 W, M into V, V into equivalent weight divided by 1000 into W. So, this is cross, VV is cross. So, equivalent weight divided by molecular mass weight. Okay. Now, from the previous definition, you already know that equivalent weight means what? Given mass, molecular mass divided by what? Equivalent number. Molecular mass divided by equivalent number. Equivalent number, if we symbolize by E, then here it is M. So, look at here. Finally, you can write S by N equal to M by E, that is 1 by M. I repeat here, molecular mass divided by equivalent number. Just we have taken a symbol that is equivalent number E. So, we can write M by E, because you know that equivalent weight equal to molecular mass divided by what? Equivalent number. Now, finally, crossing this mm, so 1 by E. So, N equal to S into E. What is this? Normality equal to molarity into equivalent number. Again, normality equal to S into E. Normality equal to molarity into equivalent number. Okay. Now, if we do a short maths, for example, what is the molarity? What is the normality? What is the normality? Normality of 2 molar H2SO4. It's very simple. Okay, you know that N equal to S into E, easily convert. You know that H2SO4 equivalent number is 2. So, N equal to here molarity value is what? 2 molar. So, here 2 into 2, that is what? 4 normal. So, this is the 4 normal. Okay. So, normality can be find out easily from this given data. Okay. So, dear students, keep well all the time and follow this lecture. Inshallah, lecture 3 we will do more maths. Inshallah. Till then, Allah Hafiz. Assalamu alaikum.